Thermal energy, also known as heat energy, is the kinetic energy generated by the movement of particles within a substance. Let's explore some real-life examples to see how thermal energy can be observed in different scenarios. Hot tea. The hot tea possesses thermal energy as a result of its high temperature. Bathtub. The bathtub filled with hot water contains thermal energy due to the elevated temperature of the water. Hot pizza slice. A slice of piping hot pizza retains thermal energy acquired during the cooking process. Sun rays. The sun emits radiant heat, which transfers thermal energy to the surrounding environment. Boiling water. The vessel of boiling water on a stove exhibits thermal energy as the water molecules gain kinetic energy and heat up. Cooked food. Cooked food retrieved from a microwave oven retains thermal energy acquired during the heating process. Drinking water. The water that melts the ice cube possesses thermal energy, transferring heat to the ice and causing it to change state. Hands. When you hold a cold glass of juice, your hand transfers thermal energy, warming the glass and bringing it to a more comfortable temperature. Matchstick. The ignited matchstick generates heat as a result of a chemical reaction, producing thermal energy. Heater. The heat emitted from a heater radiates thermal energy, warming the surrounding space. Skillet. The skillet placed on a stove absorbs heat from the burner, acquiring thermal energy to cook food. Toast. A piece of toast coming out from a toaster carries thermal energy, as it has been heated to a desired level of crispiness through the toasting process. So those were the examples of thermal energy. Now let's explore the equation and solve some practice problems based on that. Thermal energy equation is commonly expressed as Q is equal to mc delta T, where Q represents heat, m is mass, C is specific heat, and delta T is the temperature change. This equation helps calculate the amount of heat transferred in a system based on mass, specific heat, and temperature change. Let's solve some practice problems to apply and understand the thermal energy equation. Calculate the thermal energy required to raise the temperature of 1.8 kilograms of aluminum from 5 degrees Celsius to 45 degrees Celsius, given that the specific heat of aluminum is 0.9 joule per kilogram degrees Celsius. Write down the given data, plug in the values into the formula, and find the thermal energy as requested. We need to determine the thermal energy, so Q is equal to question mark. The mass is given as m equals 1.8 kilograms. The initial temperature, T initial, is 5 degrees Celsius, and the final temperature, T final, is 45 degrees Celsius. Therefore, the temperature difference delta T is equal to T final minus T initial, which is equal to 40 degrees Celsius. The specific heat is given as C equals 0.9 joule per kilogram degrees Celsius. Insert these values into the equation Q equals mc delta T. Therefore, the calculation becomes Q equals 1.8 multiplied by 0.9 multiplied by 40, which equals 64.8 joule. Hence, the thermal energy needed to increase the temperature of aluminum is 64.8 joules. Let's take one more practice problem. A 600 grams of sample undergoes heating, with its temperature increasing from 25 degrees Celsius to 75 degrees Celsius. Calculate the thermal energy required for this temperature change, given its specific heat is 1.2 joule per kilograms degrees Celsius. Write down the given data, insert the values into the formula, and calculate the thermal energy as requested. A 600-gram sample is given, so M is equal to 600 gram, which equals 0.6 kilograms. The initial temperature, T initial, is 25 degrees Celsius, and the final temperature, T final, is 75 degrees Celsius. Therefore, the temperature difference delta T is equal to T final minus T initial, which is equal to 50 degrees Celsius. We need to determine the thermal energy, so Q is equal to question mark. Also, the specific heat is given as C equals 1.2 joule per kilogram degrees Celsius. Place the given values into the equation Q equals mc delta T. So the calculation becomes Q is equal to 0.6 multiplied by 1.2 multiplied by 50, which gives the value of Q as 36 joule. Therefore, the thermal energy needed to raise the temperature of the 600-gram sample is 36 joule. So, that's a wrap on thermal energy. If you enjoyed this simple explanation, like the video, share it with your friends, and subscribe to the channel.